Hey, this is Mr. Hansen. I wanted to focus on exponential functions today, and I needed something to compare them against, so we're going to look at a linear function first, and then we'll move into the exponential function. So notice this table right here. When x is 0, y is 3, and if we were to kind of graph that, x is 0, y is 3, and then x is 1, y is 5, and x is 2, y is 7. You can kind of see each time we go over 1, we're going up 2, over 1, up 2, and so on. And so it makes kind of a stair pattern if you made some slope triangles and you have a line there. And one way to think of this is repeated addition. So we're just adding 2 each time we increase by 1 on x. We add 2 on y. And so there's a constant rate of change. It's just increasing by 2, and so that's a linear function. Let's take a look at this exponential function. Oh, by the way you'd write this linear function is f of x equals 3, because that's where we started, plus 2x, or you could say f of x equals 2x plus 3. It means the same thing. The 3 is my y-intercept, and the 2, or 2 over 1, is my slope. It's the rise to run ratio for these triangles I've made here. Okay, let's take a look at an exponential function, and maybe just to give you maybe an idea of how this might be used, think of a bacteria, and the way bacteria multiply is they split in half, so they double each time. So we have one bacteria at stage 0. At 0 hours, we have one bacteria in a petri dish. So maybe and I'm going to count by 4s this time. So 4, 8, 12, 16. So we have one bacteria right there. And then at 1, it's doubled. So we have 2 bacteria right there. And so at 2, we've doubled again, we're up to 4. And at 3, we double again, from 4 we're up to 8. And at 4, we double again, we are up to 16. And at 5, we'd be way up here at 30, 32, way up there somewhere. So you can kind of see a curved pattern right here. And what's happening is each time I go over 1, I'm going up twice as much. So you can kind of see these steps increase by a factor of 2. They get twice as big each time you go over 1. You get twice as much. And so that's why there's a curve to that exponential function there. So the way I might write this as an equation is g of x equals 1, because that's my y-intercept. So 1 times, and I'm doubling each time, so I'm timesing by 2 to the x. 2 is like my multiplier. It's what I keep multiplying over and over and over again. So 1 times 2 to the x would be this exponential function here. If we plugged in g at 6, it'd equal 1 times 2 to the 6th, and that's 64. So that's kind of how this works with exponential functions. Just one last question I want you to think about. With a linear function, we could kind of draw the line going on and on forever in both directions, kind of like that. With an exponential function, if I'm doubling going forward, then going backwards, I'm halving. So I'm half as far away from that x-axis each time, so I just get closer and closer and closer to the x-axis and never actually touch it. It looks like it's touching it on this, but you never touch the x-axis. And that x-axis is what we call an asymptote. It's a line that your graph gets closer and closer to, but never touches. And hopefully that makes sense, because we're just halving the previous number, and if you'll just take a little bit, half of the number in front of it just gets a little bit smaller and smaller and smaller, but never quite reaches 0. Okay. Let's look at some exponential functions. This first one, 2 times 3 to the x. And maybe if you thought about a village with 2 people in it, and they had 3 kids, And those 3 kids went off and got married and had 3 more kids each, and then those 3 kids had 3 more kids each, and so on. That's kind of what's happening here. So let's say 2 times 3 to the 0, for 0, if we were to plug in 0 right there for x, 3 to 0 is 1 times 2 is 2. So at 0 generations, we were at 2 people. And then 2 times 3 to the 1, then 6 people, and then 2 times 3 squared is 9, times 2 is 18, and so on. So each generation you're increasing by a factor of 3. We're timesing by 3. And if you go backwards, you can figure out what negative 1 and negative 2 are. You just divide by 3. So 2 divided by 3, 2 divided by 9. Let me try that again. 2 times 3 is 6. Yep, it is 2/3. And 2/9. That it was right. Okay, let's go ahead and graph these. So we got 0, 2. We've got 1, 6. 1, 2. Right there. We've got negative 1, 2/3. And we've got negative 2, 2/9, and so on. And so it kind of goes like this. It's an increasing function, kind of like that. Let's take a look at this one in contrast. You can probably see a y-intercept. It's going to be 20, and then our multiplier is 1/2. So let's put the y-intercept in right there, and let's put in 1 for x. 1/2 to the 1 is 1/2, and half of 20 is 10. And then we have 5, and at 3 we're going to be at 2.5. Hopefully you see the pattern. We're just halving each time. So let's count by 4s. 4, 8, 12, 16, 20. So there's 20, and then 10's right there, and then 5's right there, and then 2.5's right there. If we went back 1/2 to the negative 1, same thing as 2 to the positive 1, times 20 would be 40. So we're way up here, and so it kind of goes like that. So what is it about this one that we just did that makes it decrease, and the one that we did before it that makes it increase? What's this number right here? If the number is bigger than 1, if you do repeated multiplication with a number bigger than 1, you're going to get a bigger and bigger number for y. If you do a repeated multiplication, and that's what exponents are, is a repeated multiplication for a number smaller than 1, 1/2 of a half is a fourth, and 1/2 of a fourth is an eighth, and so on. So you'll get a decreasing kind of graph like this. Okay, both these graphs have asymptotes. They both get closer and closer to that x-axis. And if we wanted to write the domain and range, what our possible inputs and outputs for this graph would be, the domain at this point is all real numbers, but the range, you're not going to have negative numbers, so y would have to be bigger than 0. Same thing for this one. Domain, all reals, and the range, that's your outputs. Y has to be bigger than 0. So that's a bit of an explanation of exponential functions. The big idea is that it's repeated multiplication, and when you multiply by a number bigger than 1, you're increasing. When you multiply by a number smaller than 1, you're decreasing. Also, we have a y-intercept that's out front there, and this idea of the graph touching getting closer and closer to a line, that line's called an asymptote. And in contrast to a linear function, it's repeated multiplication instead of repeated addition. Hope this helped you start to think about exponential functions. Thank you and have a good day.